Hello, fantastic Blair sixth graders. I wanted to review with you the sort of question that I might ask you on tomorrow's quiz. Tomorrow's quiz is all about the work we did in the activity, the lab activity on Wednesday, where you shone a flashlight at the globe and then you traced around the area of the light at two different locations. One was at the poles and one was at the equator. And then I asked you to make a calculation, that calculation being the ratio of the amount of light per unit square. So here and here, I'm going to calculate that for both of these examples, and then we'll talk about which one of these might come from the equator and which might come from the poles. So the first thing you need to do, and I will ask you this as a separate question, I'll say, hey, what is the area of this, of this shape? So let's do this shape first. And so this small space, I'm just going to count real quickly. There's like 1, 2, 3, 4, 5, 6. We're going to call that 7, 8, 9, 10, about 10. So I'm going to say that's about 10 square units. So there's about 10 little squares in here, 10 units of area. And then I'm going to do the same thing for this one over here. Now I estimated that a little bit earlier, and it was about 115. So I know that the area of this is about 10. The area of this is about 115. The next thing you do is you are going to find the ratio. Remember, the ratio is just a relationship between two numbers. The ratio of light energy per square. And per is your clue that it's a ratio. And per also, it sort of means for, so how much light energy is for every square that's in every square. Well, that means to calculate it, we're going to put the amount of light energy on the top of the ratio, and what comes after the per goes on the bottom, how many squares. So I've been saying, you know what, it's about 100 units of light. And then I said there's 10 squares. So you're going to set up the ratio like this. A ratio, it's kind of like a fraction, right? And so you take the number on top divided by the number on bottom. So 100 divided by 10 is, it's 10. So 10, and then your unit is all of this right here. Units of light per square. All right, so here is my answer to that. Now what if I took that same flashlight, shown it here, and I had a much bigger space? Well, the ratio is going to be the same thing. The units of light, which is still going to be 100. Same flashlight. We're not changing how much energy it's giving off. Units of light. We're not changing how much, GHT, we're not changing how much light it's giving off. But there's a very different number of squares here than here. That's going to be 115 squares. And then I'm going to do the math, and I'm going to do what, and I can't do math in my head very well, so I've got my calculator right here, and I'm going to take 100 divided by 115. Before I hit enter, is this a number that's going to be bigger than 1, or a number that's going to be less than 1? If I look at this, my numerator is a larger number than, or excuse me, my numerator is a smaller number than my denominator. My denominator is a larger number than my numerator. So I know that I need 115 115ths to be 1. So it's not quite 1. It's almost 1, but it's not quite 1. Let's see what it is. Oh, it's this huge crazy number. And then if you remember, I said whenever we're doing math with what we're doing, you can always round to the nearest tenth. That's this first place right here. So I'm going to say 0.86, round that up to 0.9 units of light per square. And what these numbers give us, what these numbers tell us, is the intensity of the light, how strong the light is, how powerful the light is. So here, if you have that light spread over a small area, it's pretty intense. It's a lot of energy for every one square compared to this, which is a much smaller number, because the light here is spread out over a much larger area. So, estimating or calculating, I should say measuring the area, calculating the intensity, the ratio of light to the square area. The next question I want to ask you is, okay, is it from the equator or from the poles? When you were looking and making observations of your globe, you noticed that the light at the equator covered a much smaller area and was almost always a perfect little circle. But by the time you got up to the poles, it was much more spread out. Maybe it was even, sometimes it even went right to the edges of the paper. It was not necessarily shaped by a circle, shaped like a circle. Sometimes it would be round at one end and then really spread out at the other end. So that tells me that if one of these is at the pole and one of these is at the equator, the smaller area is almost like a circle. That's going to be the one that represents the equator. The spread out one that may be circular, but often is not circular, that is going to be from the poles. So that's the sort of question I'm going to ask you on the quiz tomorrow. I'll give you information about the area. I'll give you information. I'll give you the drawings. I'm going to ask you to count up the squares, determine the area. It's multiple choice, so I'm going to give you some information about what would be the most reasonable, or given this information, what would be the answer for that ratio, and then which one is the equator and which one is a measurement from the equator, which one is a measurement from the poles. So, if you've got any questions, you can ask me. I'll be at school early tomorrow morning. You can ask me before the quiz, and I'm always happy to give you some guidance, to give you some help. See you tomorrow.